Alright, John. First one is a 3-inch face mill.
I'm sort of writing the tool down and then.
No, let me just put that on there so we keep track. So, right here you look, it says, you have to figure out again first. So, surface feet per minute times 4 divided by the size of the gutter. All divided by the size of the gutter. So we know surface feet per minute. What is it again? Times 4, right?
Times 4.
All divided by
Divided by the size of the cutter.
like that. Equals R. E. Little lag. Not bad. So now, all we have to do is answer these questions. So our 3-inch face mill has carbide inserts. Correct? So what is aluminum? And it says right here, milling, turning, cutting speeds as SFM, surface feet per minute. So all you have to do is you're going to have a carbide.
Yeah.
You go down to aluminum, so it's 800. So you do your 800, got a calculator? For your phone, times 4. And then our cutter's how big? It's 3 inches, right? So do this in your calculator, hit equals and then divide by 3. You see how I got all those?
Yeah.
Surface feet per minute, 800.
Times 4. Oh, wait, right. Yeah. The cutter is a 3-inch.
Yeah. So 800 times 4, and then hit equals and then divide by 3. That one shouldn't matter, but that's a good habit. 8, 12.
Yeah. 1,066. 166.
1,066. And do not forget the decimal point, because if you do, remember it moves the decimal place over to the left. Hold on.
Yeah, I figured that out the hard way. I was on the machine and I was like, it was for that first part.
So there's your RPM for your 3-inch face mill.
Yeah.
I write it numbers like that so we can go back later and you're confused to know.
Yeah. You can continue.
Are you done?
I'm ready to last two.
Okay. So then, here's the next one. 750 a mil. So you take your formula, and you know everything that's not a carbide insert here for your class is going to be high-speed steel. So your surface feet per minute for high-speed steel aluminum is 600. So you do the 600 times 4. Like this. And then you divide by the size of the cutter, which is
0.7. 30.
0.7.
3/4. Yeah.
Yeah, 3/4. Same thing.
Whatever the.
So then do the math on that and tell me what it is. Decimal point. Sounds about right. So now the spot drill. When we do a spot drill, we go by the size of the hole in the print. Because you're not going to use the entire cutter, you just want to cut to that size. So can you pull your print up on your computer? Maybe only get so much door for your lungs. So I want a little chamfer on this hole. And I want a little chamfer on this hole. So the first hole is going to be.
You want to check on that one too?
I put a chamfer on this hole. I put a chamfer on these two, just the outside, because this is a counter. Does that make sense?
Yeah.
Your chamfer's going to be up here. Didn't you guys make a vice job in your class already?
We started. That's the week that I was like.
See?
Yeah.
The mystery gauge. So, this is how you're going to get this out here. See it?
Diameter is 52 or 20.
So, the diameter of the balloon on the side, not
Oh, wait, that's the blue. Yeah.
755. So, you do the same thing except use the diameter of your hole. So, so you put the diameter
For the chamfer?
for the size of the tool. So, hang on a second. First things first, we do the size of the hole for the cutter, because depending on the size of the hole, your speed's going to vary. So the first one was 755. So we want a little chamfer. We'll just say 800. Okay. So you do 800. I still got to erase. 800 times 4 divided by. Oh no, I messed up. My bad. This should be your surface speed. What was surface speed for high-speed steel?
For aluminum?
Yeah.
600.
So this should be your 600. Surface speed per minute times 4. Now you take what you want the outside of the hole to be. So since we want a 25,000 chamfer, you said 755. We'll make the math easy and we'll say it's going to be 800,000. Okay?
So would you want to round up or?
What?
Because it's 755.
Well, that would give you a decent chamfer over there. That might be too much. Maybe you only want to go. If you want to go like 7, it's kind of up to you to a point. Because you know that hole's going to be 755, and 10,000 chamfer is almost nothing. So 20,000 you can add 40, which makes it what, 795? And this is up to kind of your discretion, okay? On that chamfer, because it's not on the print, right?
Right.
So then you got 600 times 4 divided by that. Which gives you what?
Zero. $3,018.
3,018. 0, 1, 8. Like that?
Yeah.
So now we're going to do the same thing when we get done. We're going to do it for the smaller hole. So say you want a 40,000 chamfer. We'll keep them all the same on that little hole. And the little hole is how big? 20. Quarter. Yeah. So a quarter plus 40,000 is. So we do the same 600 first, right? Because we got high speed steel again.
Right.
And then your 290 would be 40, right?
Wait, we're on the spot drill right now. Okay.
Yeah. This was the spot. The spot drill for these two will be the same RPM, but this whole
Is the
smaller.
chamfer gonna do the spot drill?
The spot drill is the chamfer. It's going to chamfer and spot drill all at the same time.
So.
Is your fine? I can pull it back.
No. I just thought the chamfer was with the end mill for some reason. I was like,
See, this is the size of the chamfer.
yeah.
So that's
Yeah.
what
No, I understand all that. I was just confused on.
So then your smaller mold, if we do 250 plus the 40,000 chamfer, it's 290, right?
Yes.
So then do the math on this, and this will be your little hole.
Shit.
Oh, that's gonna be fast. It'll probably be too fast for the machine.
Said 8,000.
Shouldn't be that.
Maybe even redouble. Yeah, 8,275.
Depending on what machine, depending on what machine you're using, it may or may not run at that speed. Because that's getting close to single max on some of our equals. Does that make sense?
Yeah.
That's pretty quick. Honestly, if I was programming it, I'd probably cheat. I'd put like, what was the one up here?
That one was 3,000.
I'd probably put like 4, honestly. Just because I know it'll work. But this is technically right, so you can try that. Because this is right by the book. This is basically what it should be.
And that was for the reverb, right?
Now that's for that spot drill for the center hole. We're doing one side. We did the face mill RPM.
Wait.
Then we did the end mill RPM. Now we're doing the spot drill RPM. It's going to be different for these two. So the first spot drill was for these two, okay?
Yeah.
The second spot drill is for that one, because they're different.
Yeah.
So then now we're going to do, now we'll do the drill and the reamer. Okay? Alright. So, our reamer is, or let's see. You have drill cutting speeds, surface people are going down here. See, you have, oops, that's really messed up. That's why it's so high. I should have told you to use this one. See how it's got,
Because of the drill, right?
yeah, it's drill, so it should be over 200. So let's go back and fix it.
For the big holes too?
Yeah. Because see, it says,
Right, no, yeah, you're right.
this is for inbuilds. This is for drill, countersink, reamer, and tap. So it says countersink should have been, literally it's a spot drill. We can go 300, but that's going to make your numbers a lot different. So here's what we do. This was your first one, right?
That was, yes.
So we're going to get rid of this. We're going to turn this into a 3, because it's at 300 for a drill.
Yeah.
So now do the math on that.
Wait a second, I gotta rewrite some things.
Should be basically half.
Divided by, 1509.
Yeah. Told you half, right?
Yeah.
1509, period. Now let's go down here and do this one. So turn this one into 300. And then we'll change this. And then we'll bring it down to, whoops. We'll bring it down to more like 4,000. No. Which I think is way better. This actually got my book, so I guess it's going to be
What you going over?
okay.
What you going over? What are you going over?
Speeds and peaks first.
I see it.
Apparently, if I had to write the fix right there.
Damn.
I'm glad they fixed that. That's so easy. It's so much better than driving on a dry erase board.
Yeah.
Because it's the endless dry erase board, you just drag it up as you go.
Oh yeah, it's so much better than like, and then also the
I don't have to crawl on the floor like I did last year.
the ink and stuff is also like reflective as well. So like it reflects just the same as dry erase board, so to make sure we'll see it if the light was hitting it.
Oh, right.
So you're saying it'll show up in the camera better?
Oh yeah, much better. Should be. All right, I guess I'll see you tomorrow.
Yeah, it's more like
4,000.
4,137.
Remember, whenever you're doing a face mill, take off at least an inch.
Yeah, no. I tried that one time.
How'd that go?
I hit the E-stop button, or not the E-stop, the feed hole button rather quickly.
On which one?
Face mount.
Face one.
That 3-inch face mount. I got my offsets confused because I was using two different sets of offsets and got into oopsie.
And then now we're on the reamer.
Now we're on the reamer. Okay. So what's your surface speed per minute for a reamer?
That would be 150.
150. So 150 times 4. And what size is said reamer?
Duh, quarter.
I was making you figure it out.
Is it?
Yeah, it's quarter.
Oh,
Okay.
I read this.
I said that to make you think. So 150 times 4, that's going to get you, let's see, 300, 600 divided by quarters, so that's going to be 6, 12, 2400, right?
Year.
Make you crazy when you do that by hand.
Not really. My dad does it pretty fast. He does pretty fast math.
Oh, we forgot the drill bit for the reamer. So this is the reamer,
Oh,
okay?
Yeah.
So let's do the drill bit. And we usually do RPM for one and then the feet speed for the other, but I thought this would help you get used to it better. Does that make sense?
Mhm.
So let's do, what's the drill bit on it, or sorry? 200? So then for the drill bit, it's 300 times 4, and a good estimate for a reamer is probably 1,500, 2,000. So let's do, we'll do 20 under. 0.2, 40. That's a little extra material. Oops, I'm at 30, not 40. That's a little more material than we think sometimes, but so now do the math on that, and this will be your drill.
$5,217.
5,217. I'm gonna erase that. Whoops. 5,217. And if we compare it to our reamer speed, that's about right. Because what's the general rule in manual? Twice the speed, half the feed, right?
Yeah.
Twice the speed.
It rings a
Or
bell.
half the speed.
It rings somewhat of a bell. I forget basic stuff pretty easily.
Half the speed, twice the feed. So 5,000 divided by 2, 2,400, really close. See how all this kind of relates back to manual machines?
And then that's the drill bit, right?
Just the drill bit. And then we have the 530 drill. So we have the T6 down here, the 530 drill. So your drill bit you said was 300.
Wait, so,
This is the drill bit for the tap for the reamed hole.
but for the drill bit, it's gonna be 20. Oh, wait, never mind.
To answer the question.
I think so.
Okay.
No, I'm just confused on what tool we're using the tool for.
And my board is still working. Really? That's not fun. Oh, it's still the thread. Try what? Oh, there it goes. Let's just do that. So, okay. Now we gotta do the big drill bit. Tool 6, right?
Yeah.
So 300 times 4. What do I divide by?
What, 300, by 500, or 530.
Yep. So do the math on that one.
2,264.
2,264. So there's all your speeds. Every one of your RPMs for the whole program. Okay? Now we've got to take your RPM and we've got to go back and figure out your feed rate. Because it's the only other thing you gotta have. And what's your feed rate in your program? It's the letter No, what's the letter in program, you remember?
Oh, F.
So,
Oh.
I did this a little different because I thought it'd be easier for you, so. What was your RPM for your 3-inch? Remember?
The RPM was 1066.
1066. Sounds about right. So now, if you look in your book, you guys. Actually, do this right here. RPM, okay, times chip load times number of flutes. RPM. See where it says that? Times chip times flutes equals rate. See where it says that? Right here?
Yeah.
So now you probably guess what we do, right?
You take the RPM and then
Figure out that RPM chips, RPM at 1066, and the chip load is on the next page, and it's different for carbide and fluid than it is.
should I be writing down that it's carbide? Or I guess what is it?
As long as you do it. So, our mill is greater, our cutter is greater than an inch, right? So it's on a chip load of 7,000. Okay, so that's where you get your chip load, it's off that page.
Oh, that page.
Times the number of flutes. Remember how many flutes that Sean has? Yeah, it's 5. So now do the math on that. 1066 times 7,000 times 5.
Um, 37.31.
66 times 37.31. So that's 37.31 inches a minute.
Would you put like IPM?
No, you don't have to do anything, but yeah, that's the abbreviation. The abbreviation would be inches per minute like this. Okay?
Oh, I don't.
But on the program, all you have to do is put F of
F.
37.31. Okay? So next one. RPM for your 3/4 mil.
Oh, 3200.
So you do 3,200 times chip load. So that's under an inch. So you find the right one. You see this says a diameter of a half to an inch, right? So we'll use this one. 6,000 times 6,000 times number of flutes.
Duh.
It'd be 3, it'd be 4. We'll go with 3. How does that sound?
Yeah.
So 3,200 times
57.6.
57.6. Like that. Right.
Yeah.
And then we just do the same thing. If you notice down here, we get to the labor, it's kind of different. Everything else is based off of this. The labor's different. Everything else is based off of these guys. this is not ridge lines. Yeah, so this is your ridge lines for your next 12,000. So your chip load must come up here. So then, let's do we'll do one of the spot drills, and then we'll do the reamer and drill it. So what was RPM on your first, on your 3/4 spot drill?
That was for the big hole or small hole.
For the big hole.
For the big hole, it was 1509.
1509 times chip load, and we said that hole was smaller than 600. So it would be either this one or that one. What's the diameter of the cutter?
Everybody's all
So it's 6,000. Times 3. We'll get
Wait, is spot drill all that back?
oh no, it's supposed to be 2. Well, wait a minute. Depends on what spot drill. Most the spot drill should be 2. That's my bad. You caught me, didn't you?
I'm gonna say that. Yeah,
So there you go. Do the math on that one.
2. Oh shit. I got 18 when I won, but I think I did that. Try.
Yeah, let's see what that's.
Yeah, 18. Oh, 18.1.
That sounds better.
Sorry.
18.101. Alright, so let's do the reamer. And then surely you got it by now, don't you?
Oh, 108. Sorry,
Figure
not
it out.
101. 18.108. Not 101, sorry. That.
108.
Does that decimal matter? Or?
This does. This
No, I'm saying
that's
that
not very
decimal
decimal
place. Like if it was a 1 or if it was an 8.
I usually do once it's a tap, I usually do 1 by the decimal. So I would have left.
You just left the 1.
Because it's at 18.1. Now if it's a tap, you can't do that.
That was strong.
That's something you can do because your program's not a tap. Tap's a little different.
And then the
That's the tap.
small.
That's the one for the big one. Can you figure that one out?
Yeah.
So let's do
Should be able
the reamer real quick. So what's your reamer RPM?
to. The RPM is 2400.
2400. And then I don't know how many flutes the reamer has without going again. So don't write this down. Okay?
I think it's 6.
I was thinking of something like that too. So what's the chip load on the reamer? Or any?
The chip load is up.
Chip load for a quarter, right? So this is smaller, 125.
So
That's a quarter, so it's going to be that. It's going to be 2,000.
what about that?
Oh, a quarter. Yeah. I'm looking at it upside down. 5,000.
Oh,
You're right.
okay, yeah.
And remember, I'm looking at it upside down.
You're right.
Because if I walk over there, that means the camera can see this, so you can see this later. And then you said you thought it had 6.
I'm just guessing.
So do that. What's that?
So I have no idea, I'm on 3rd part, I have no idea how to set this up, and isn't it supposed to have like a dial on it?
Yeah, that's in your box. It's a test. Then one of your.
I don't think I had one, because I told you.
Oh, no, you're the one that have one. Just borrow it. So,
Okay.
and there's
Also,
a few out there that's done that, so it didn't help you. We're gonna grab one of my 18s off the cap. Tell them that's what we make it up.
Okay.
They know how to do it.
because I talked to two of the 11s, and like, one's been through it and just said that I'm SU.
We'll grab one of the 118. For this to work, everybody's got to work together a little bit. You know what I mean?
Yeah.
I love to what I've done with him though.
72 is what I got.
72.
For the reader.
Okay. So now you pull up my program. That's right here, right?
Oh yeah, I have that up.
Then you go to your
Do you want me to
lines.
do the, what was it, the other drill?
We'll do the tacker.
Drill bit and then the
The
drill?
drill bit's the same as everything else. You just have to put in the numbers right in formula, right?
Yeah.
I mean, I'll help you if you get stuck. So, when you go through the program, you'll eventually know what all this means. Okay? So G1 is a linear move. This G1, if you look, it's just, it has a Z, right? So it's a 0.1.
Okay, yeah.
So
See,
Z is up,
then it's just like,
Z is up and down. I just slowed it down before it went down so that it wouldn't go down rapid, like that. So then, this is your first actual feed move. X of, you're gonna start here where the G54 is. So G54 X 5.5 Y 0. That's where you're at right now.
Yeah.
You're gonna drop down beside your part, and then it's gonna go to negative 5.5 at a feed rate of 60. So, whatever feed rate you got, it wasn't that high, was it? You wanna just show
No,
it?
it was 37.3.
So you gotta replace that with that number.
Yeah, and then make sure that it's F37.3, right?
Yeah, see the F right here?
Yeah.
You just gotta fix it and change it. And then up here,
And then whenever I'm done.
where I turn the spindle on, which was right here, see this S2
yeah,
500M3?
yeah.
That's your spindle speed, so you have to change that.
Yeah, I remember that.
So,
from last year.
change the S, change the F, change the S, change the F until you go around. Make sense?
Yeah.
So let's do tap.
Because
Because tapping is important, you have to get it really close, so that thing will happen.
is that the 3 or 5 30?
Right up, because you're project's
Oh.
gonna tap it.
How does that happen?
You don't have to tap on that part, but your project that you have to write this. So,
Wait, what?
your tap that's, your program that you, this is my program. So
Yeah.
you run my program and you're gonna write one similar to it,
Oh, okay.
but different. Does that make sense? Yours is way simpler than mine, I think you have a tap hole. So if you go down here
So am I
to,
making 2 by 2 or 2 by 2?
no, it's, I'll show you, it's in Canvas, it's in a different part. Calculate tap feed for, calculate tap feed for this, do this one divided by TPI times RPM, okay? In this class, we're gonna use 100 for RPM, I'll just give it to you. Always 100. 100 for the RPM. So you've got 1 divided by TPI. 1 divided by TPI. Times RPM.
Sounds good. So times the
Exactly. Then. So, that's your formula right there for your tap. So it's just like all the others. TPI stands for what? Threads per inch, right?
threads per inch.
So if I say we have a
Yeah.
quarter 20 tap, what's the TPI?
The quarter in the inches is the inches, right? So you
The
go,
quarter is diameter, sort of. Your outside of your tap's gonna be really close to this, okay?
yeah.
This is your threads per inch. So if I'm doing a quarter 20, 1 divided by 20 times 100. And on this one, what do you get?
Is that it's just 2,000.
No, here. 1 divided by 0.2.
Oh, it's 0.2?
Or no, 1 divided by 20. Yeah. I'm doing math in my head. That's where I'm going wrong. 5. That makes more sense. And
That definitely just did 25.
then you go out at least 2,000 places, maybe 3. Okay?
Okay.
So let's do one.
And that's check to it. Tap feed, right?
And you already know the RPM because I told you 100 for this class. 100 is even, that's what I usually run on the paper machine. So then, let's say that I've got a half 13 tab, which I think is what yours is in your project. So it's 1 divided by TPI, which is what?
Sorry, I was right on the last.
No, you're fine.
13.
Yeah, 1 divided by 13 times RPM, which I said was equals. Maybe we can do that.
$7.692.
7.692. Make sense? So everything needs on those 3 pages in your book. Our formulas here, stuff that goes in the formula here, and then the other stuff that goes in the formula here. And then when it comes time to figure out what size drill bit you need, it says 12 thousandths for your reader. See, I told you 20 is too much.
For the, wait, what do you mean?
Remember I said when we left 20 thousandths for the reamer? I said that's a little too much. And it says right here for, that was a 1/4 inch hole. Yeah. Remember on the reamer, on the part that we had first, right here? I didn't give you the size of the drill bit on purpose, because I wanted you to figure it out.
Oh, okay.
So what does this say? This says leave, for a 1/4 inch hole, it says leave 10 thousandths, right? So according to that, your drill bit should be 240. That's leave 10 thousandths.
For 204s, maybe 240?
Stop. Additional extensions. So that could be 20, or that might be 10 aside. I wouldn't quite know. That was it. That's probably good 10 aside too. Probably this one. That was probably good.
24.
This is the only question I have with the way this is written. This says for a reamer of a 1/4 inch, which is what we got, right?
Oh, okay.
It says you're supposed to leave 10 thousandths, so is that 10 thousandths on your diameter, or is that 10 thousandths per side? I'm sure it's 10 thousandths per side, because 10 thousandths overall, I'd probably clean up all the way, so that'd be 20. So your drill bit would be 20 thousandths smaller than your reamer. So if you've got a 250 reamer minus 20 thousandths, what size is your drill bit?
So it'd be 24, or
2.4, 2.4, 8, right? Make sense?
you're making.
Or actually, no, I lied too. It should be smaller. So what is 20 thousandths smaller than that?
28.
230.
Yeah.
Thought I was something wrong. So that's the adjust of your speeds and feeds. So now you know how to fix your speeds and feeds, and you can run this program. Okay? So, I have to flip your notebook over so you can take notes on what you change. We're going to go through this. Hopefully, it'll let you understand a little bit better. Oh wow, you can see that pretty good on here. Cool. So, on the page of your book that has your drilling geometry codes. There's one set that's laying, one set that's not. This says no. Oh, okay. Yeah, you did. These are your G codes. Your G codes cause movement. They make things move. Spindle turn on, go from X to Y, drill a hole, that kind of thing, okay? Your M codes are like light switches. They turn things off and on, like program stop, cool it on, cool it off, tool change, stuff like that. They cause things to happen, not movements. I mean, tool change is technically a movement, but that's the easiest way to understand them at first, at least. Does that make sense?
Yeah. No, I mean, I know what they do. It's just like memorizing.
Yeah, it's going to take time. So, we'll go through this program. You have this program in Canvas. This is the one I use.
Groups. It says code.
Good question. Maybe have but so we'll go through this one. This one's already in Canvas, and I want you to write like I do to write words. Okay?
Can you repeat that? Sorry.
Write like I did when I wrote this one to write the word you're gonna write. Okay? Does that make sense? I want you to follow the same method I do. So, first thing to do is always start with the percent sign.
Yeah, I heard you have to start it in.
And then this is a letter, not a number. Okay, that's the letters. The letter O, not a number.
Yeah.
Okay, you guys have a slash in the middle. And then 4 to 5 numbers. You have the description that I used. We went over this a little the other day, but I went really fast, didn't I?
Yeah. Just a little fast.
T1 is tool 1, because this year we decided that your probe is always going to be the very last one. So on your mini mills, they go to 1 to 10, correct? So the probe will be number 10. On the BF3s, they go 1 to 20. So the probe will be in 20. On the 750s, they go 1 to 30. So the probe will be in 30. Actually, the probe's in 31 because they hold 1 extra in the way. Because the tool holder chamber works. So the tool and those are in 31. However, the BF3s do not put the things back in the same hole. The only way to tell where the tool actually is to look at your offsets in the list. The 750s. Because you know, like, the mini mill and the BF3s, they put it back in the same one they took it out of, right?
Oh, yeah.
The 750s will put it back in the easiest one to get to. That's empty. So you might end up with your probe in, like, tool 3, and it's actually tool 31. If you look at the holder. So on the 750s, you have to look at the computer, not at the holder. Make sense?
Yeah.
The 750s are the 5-axis. Follow? You are going to just run those at some point.
5 axis?
We're going to run these 3s, but Justin's a runner, so run. Make sense?
I'm getting there.
It's like, if you don't use the other 2 axes, it's just a 3-axis machine. As long as you have your vice straight and the table straight, you can run Z, X, and Y, and it won't touch the other 2.
Oh.
Understand? So it's a 3-axis machine. You're running a 5-axis at the 3.
Yeah.
But it gives you a chance to get used to the buttons. It's got a smaller vice. It works a little different. You know, that stuff. It has the next gen controller on it, which is really cool once you get used to it.
What's up with the
The next gen, it's touch screen and all that.
Oh, shit. Fancy.
Yeah. So, alright.
Next thing you know, it's gonna be a smartphone.
Maybe smartphone product running.
Sure. You get like one of those dongle cords and just hook it up.
It's smartphone almost running that. Probably would. If you had the software on my phone to
Sure. Honestly, you probably could.
Those are Wi-Fi connected.
Especially
It's up to my
home.
home.
Run the program or some shit. However that worked out.
So, okay. First things first, you always put your tool number and a description. I do. It makes it easier. And then I wrote in here what some of this means. So tool 1 M6, change to tool number 1. The M6 tells it what? Tool change. G0 is a rapid move. G20, G40, G49, G80, and G90 are all in the book. One of them look up G90. Because G80, G40, and G20
Absolute position.
is absolute positioning. That make sure your machine is an absolute.
So do you want to always end off that line with the G90?
You don't have to put it in this order.
Oh,
Every
right.
line
You
used to
say,
have
but
this.
it just has to have like
This
G90 in it though.
G0, G20 cancels the CAN program. G40 cancels the CAN program. G49.
Yeah, I was about to say I'd probably do it in
G80,
alphabetical order as well.
See all the ones with zeros? Cancel something.
Yeah.
And you can put spaces in between or not. So down here, I put spaces in between later because I found out the spaces make it easier for you to read, but you don't have to put spaces.
It does make it a little bit easier, but
It makes it easier for you guys. I think it makes it easier for me to teach. So S200, S2500 spindle speed, M3 is what?
clockwise.
Very good. G54. You know what that is?
The coordinate offset position.
So if I use G55, you gotta use G55.
Oh yeah, G54. Those are
So
the
54. I will use G55 in this class.
55. Okay.
Because a lot of times I use 54 near the top and 55 near the bottom.
Yeah, that's how the whatever part I take was 54 for top. 55.
So that's what that means, and then this is the starting position where you want to start. Okay. So if you look at your part print, we have blank spots right here. How wide's your vice, jaw? You still got that
6
there?
inches, right?
6.2. So 6.2. And if you look at the beginning of the program, I said 0, 0 was probably that center.
Dead center was
Stock is 1 by 2, X 0, Y 0, center part, Z 0, top part.
and then whenever the Z is Z0 is on the bottom of the part is whenever you do like
You have to add the,
you do like if you do the 1, 2, 3 block you subtract that and then the whatever the
yeah, you have to set your 0
height
right on top of your parallel.
Yeah.
Right?
Yeah.
So, center's right here. I want you to show you how I got these numbers. So, this is my X direction, correct?
Yes.
So you do 6.2 divided by 1, you do 3.1. Follow? 3.1 from here to
Wait.
here.
what? Oh yeah. Okay. I don't know why.
Okay? So, then you have to offset for your cutter, because I don't want to center my cutter right here on my line, correct? Because my cutter is what I said, I said 750, right? So my cutter is 750. Follow? So what's half my cutter?
You got me there. 30 or 0.375 thousandths.
So now we want to take this line, we want to move it over half the cutter, so the edge of my cutter is over here. So I cut like
Yeah,
this.
so you're not.
So you take the 3.1 and you add that to this.
To add that. So 3.475.
3.475.
Yeah, if you're adding 3.1, yeah.
Look at this. Oh, that's the face. I'm doing this one down here. Like, why doesn't that look right? Okay, so here's the left side part. This is what I did first. Sorry, I'm trying to eat piece of crap out of here. Okay? So we'll go back to that one. But we're going to do this one first. So, cancel code, you know what that means? G54. And we're getting to the location. Did you see the 3.475 you just figured out? It's right here. Right?
Yeah.
So then we need a Y. And we won't want to start our cutter on the part. So what I do is you take this distance right here, which was 2 inches. That distance is 2 inches.
Are you talking about
This
the
is
width of it?
I just drew another one. So this is 2 inches, correct?
Yes, yeah.
So half is 1. So from center line,
But it says 1.85.
we're not counting the one groove. We don't want the groove cut. So we're going from here to all the way to the top, which is on there somewhere. It's right here. Right there. See the 2?
Oh, yeah.
So we're going half. So from this point down is an inch, correct? And then what I usually do is, just to make the math easy, there's no point dividing by 2. I'll usually just add my cutter. So it's 750. Make sense? So I'm going to start down here, about half the radius away. This is my Y. This up here is my X. Okay? Right here. Which is where this came from and that came from. Do they have the same numbers? G43, that's your tool height, correct?
Yeah.
And then the H2 is the H2 always refers to the height of the tool tube. And then the Z of 1 is an inch thick. So I went down an inch because it's 2 by 1. I actually, or this is an inch above. I should go down below. So G01, feed move, because I told you weren't going down after the side divides, right? I dropped to 100 thousandths above. And I did that just to make sure you had the same move. Gives you a chance to know, oh crap, it's in the right place. Yeah. So you're 100 thousandths above. Now you're 100 thousandths below. Now you're an inch, 200 thousandths below, and I just turned the kilo on. Follow? And then I cut to a Y of the opposite of this. Because if I'm down here and 0, 0 is here, this Y is negative, correct? That doesn't even look like a Y. This is negative Y, this is positive Y. Follow?
Yeah.
So we knew what this number is, I just flipped it negative positive. And that's where that's the Z of negative. This is where the positive 1.7 came from, right there. And then the Z of 250 thousandths, that just raises you back up a little part, because then I'm going to go to the other side. So I'm going to go, I cut this side. I started here, you cut this way off, you come up, you're going to come over here, and then we're going to cut this way. Make sense? So this one is just that program in reverse. I started at G of X of 3.475 positive. This X is positive over here, right? Right. G01, feed rate, drop it back down. And then I cut to a Y of negative 1.75. So we're cutting back the other way. So now I've cut this pass here, and this pass here. So now I'm down here. So then I'm done. I just pick up and go away.
Oh, wait, you started it.
I started down here. This is number 1.
Then you go there.
And then this is start. And this is number 2.
Yeah,
Makes sense? And if you notice, I wrote it in the program, I said right side of March, and then I said left side of March.
It reminds me of my sophomore year geometry.
Right here it says left side, right here it says right side.
Yeah.
Makes
Okay,
sense?
yeah. See, I'm gonna have to do some.
It'll make more sense when you sit down and work your way through it. It makes more sense to me than I thought it did when I taught it the other day. I told Justin when I got done, I said, I didn't teach that very well. We're gonna have to do that again. I feel bad for John.
Yeah, I definitely was a little confused whenever I went home.
Like, no homework. It's gonna have to be better than that though. Alright, so I'm going backwards, but we're going back to the shell mill.
Now we're back to
We want to start our shell mill off like this, off to the side, okay? And our shell mill is 3 inches. So this radius is right? 1.5. I kind of do the same thing with the shell mill I do. I did the laser shirt. I just had 3.
What did Enoch say? He said like an at least an inch.
Well, if you add 3, you start half the diagonal off. So you're inches long. Make sense? So here's what we're going to do. The middle's here. We already decided where the 2 edges were. Correct? Which was what? 6.2 divided by 3, so it's 3.1. And this over here is x positive. This over here is x negative. So then you add, just like we did before, the 3.1 to the 3. So you're at 4.1 while you're over here, which puts your, no, it's funny to do that. 3.1 plus 3 is 6.1. I'm confused myself.
Oh, it's like,
So now we're going to start with the cutter over here so that there's a gap. And then we're just going to lower it and we're going to go all the way across. So let's see how close I came to what I was first. Over here I've got 5.5. I didn't have, or a little over half. So I wouldn't do so much haircut. So, same thing as always. Outline gets used all the time.
it's
You
just
want
the
to
same copy and paste, right?
Yeah. I mean, I think you remember it better if you type it, but
Oh.
I can't say if I write one, I don't copy and paste it. I bet they did too, didn't you? Copy paste last semester.
I did with some of them.
So your spindle speed, or your spindle line, your offset, your x, y start position. So y is 0. We stay that way we stay right in the middle. Make sense? And then G43, your offset, your height of 1, and then a Z move. So we've got Z to an inch, G01, Z2 positive 100 thousandths, right? So there's no negative sign. Turn your tooling on. I got Z0, and then I went negative. So basically, I just skimming it on the first pass. It also gives you guys a chance to go, that's not right. Because if it takes off a big cut, you're wrong on your offset, probably. So I set it down because Z0 is the top of the part, and I took it to 0. And then we're going to run it across. Then I'm just going to lower it and bring it back. So Z0, x negative 5.5, and a few rate of 60.
I need your help with something whenever you have time.
What's up?
The program doesn't have the lathe. You can move backwards away from the part whenever it does a current tool change. So the drill bit hits into the part in the middle of the tool change. Does it have a back off?
Yeah, I'm going to be in here for a little bit. Can you just run something else? Run one of the other ones? And then remember that one, and I'll fix it for you.
Alright, thank you.
Unless you want to volunteer.
I don't know what mess.
So x of 5.5, feed rate of 60. So all we're doing is, I'm going to delete this, or I'm going to erase this, and I'm going to put 5.5 so it's less confusing. Since that's what my program said, okay? So this is positive over here,
So it's not 6.1.
negative over here, 5.5. You can leave it at 6.1, it'll be fine, but I think you're better off if those numbers match what's up there. Especially since it's all getting recorded, hopefully. That way you can look at this at home.
Yeah.
So, start, finish, and then once you come off the other side, what's the finish thickness? It's like 875. You want to look on the print?
Yeah.
So we did the first one at 0, then I dropped down 100 thousandths, and I went back the other way. Okay? So, this is what we're doing. This is like the face view of the vise, okay? So the first pass I took came down and went like this. Now I'm just going to go down a little more, and I'm going to go back. Okay? So I went down 100 thousandths, and I went back the other way. And you keep the same numbers because you're just bouncing negative to positive. That's the good thing about having 0, 0 right in the middle. So I took 100 off here, then I dropped and took off 125. So I went down 25 thousandths more, and then I went back this way. So this was Z0. This was Z minus 100. And then this move right here was Z minus 125. Make sense? So it's going to go zip, drop, zip, drop, and back the other way. The last pass takes off 25 because it'll give you better surface finish. The more you take, the worse your surface finish will be. And then we end all the programs basically the same. You do a G0, a Z of something safe, like 0.1 or 1 to get you an inch above the part. M9 shuts you cooling off. M5 is what? Can you guess? It shuts cooling off. It goes off after cooling. Then wait.
Oh, yeah. Mine, they're messing with me. That's good.
It's not that, it's a typo. G91, G28, this sends the machine to home, to machine home at C0, so it's sends your spindle all the way up. This line says
X0.
G28, X0, Y0, which will send your machine to the home position, which is basically like your startup position, so it's going to shuttle all the way to the corner. If you don't want it to go all the way to the corner, you just leave the X out. It'll bring the table back and then it'll stay in the center. G90, remember what that does? And then M1 is
Stop. Program stop.
program stop. So we did these two already. I went. Now these holes, we're going to do what's called a cycle. Right? Same thing. Starts out M6, T3, tool change to the correct tool you want. This line stays the same. G54 to the first spot, which we haven't decided yet. N3, S4800, GE, this is your RPMs. Right?
Yeah.
G43, H3, your tool offset, and they start position. What I did here was G82, we haven't gone over that. This is the page number in my book it was on. If your book matches my book, that'll be the right page.
For the spot your kind of board. For what? Again, sorry.
It's for a G82 cycle. Should explain it in the book. If you have a single packet, G82.
Oh, yeah.
It takes you through all the steps to do it in the book. That's why I put the page number on there intentionally. I wrote stuff on there to help you guys. As much as I possibly could. Make sense?
What should the chip load be for a 3/4 inch counter bore? It's not in the book. For a 1/2 inch, you had it at 2000s. I had to write that down.
For a 1/2 inch, it says 2000.
That's what you told us. For somebody to decide to write it down for counter bores. I don't think it's.
Yeah, kind of what we're talking about here. Chip load.
Remember, it's quite a bit smaller than.
What'd you say, 3/4?
But yeah,
I would go by. That seems a lot.
I remember even 2000s. It really. True. Yeah.
I go with 5. Somewhere between 2 and 5. You should be able to look it up on your phone, honestly. Just Google it. As much as I hate telling you to Google it if it's not in your book, high speed steel, make sure you use a high speed steel one. Because they do make them out of carbide. Alright, so we've got 3 holes, right? We got one at 0, 0. Or not 0, 0, but 0 this way. Where's your other 2 holes? Where's your print? So it's going to be 3.875 divided by 2. So you're 3.875 from here to here. And I want from center. So you've got to have divide that by 2. And that's going to get you from here to here.
Uh, 1.937.
0.937. Okay. Now, you're also not on center line number. You are 938. From here to here. Right?
From the
From here to here is 9. Correct? So that divided by 2 is, or actually do this. So this is 2-inch stock from here to here. Okay? All we care about is how far that is from the 0. So if you have an inch from here to the center, then you take that inch minus your 938. Because you're not quite on center line, you're this side of center line. So here's my center line. It's up here somewhere. And from center line down, it's an inch. So you subtract the 938, so you're,
So 938 from 2.
well, from what? Because you're from half. You want to do half.
Oh.
So 1 minus 938. Not very much.
62 or was that 6200 thousands?
62 thousands. Yeah.
0.60.
So, draw that. Punch the little, I just did a little hole. Your center line's up here, okay? Which the center line would be y0. So your 62 thousandths on this side of that line. Oops, that's not 62 thousandths, that's 620 thousandths. Like that. Make sense?
Yes.
So that's where this came from. 62 thousandths, y negative 62, because I'm 62 thousandths on that side of 0.
Oh.
Understand?
Yeah.
And then the rest of them are just easy. They're off of this. So this is y0, where you're going left to right. Right? This is right in the middle, as far as left to right. So this is y0. This is going to be y positive 1.937. And this is y negative right here. Understand? So now at that point, we do 254 at first location. So I started over here because I started negative. Negative 1.9375 y of 62. So you know how we got there. Because I just did the y. It's down here, remember?
Yeah.
62 thousandths on that side of 0. Then we do our spindle on or our spindle speed. Our G43 offset, H3 to match the tool number. And then our height as we go down. I started an inch, go to 0.1. This is where things get a little weird. So you do a G82, which they can, what cycle? There's like different can cycles, so you have to look in your book.
Counterboard. So I did some drills.
There you go, help me, please. Two. This has hot wheel and then working on cycle. Because all these cycles, if they have a different number, you thing, so you have to look. G82, Z of negative 535, and an R of 0.1. The R is retract. That's how far it's going to come back up. No, at this speed rate, you know that. The G82 tells us to do a can cycle for this specific thing. And the depth, you remember how we figured out the depth earlier? Because I said I wanted to chamfer on the hole.
Yeah.
So the hole is actually supposed to be what, 555? Or was it 7 something? No, it says
755.
755 is the outside one.
Yeah, you're talking about
So 0. Thank you. 0.755. That's the outside one, right?
Yeah.
So then we want a little bit of a chamfer. So we did something
we did like
780 or something like that, right?
790 or something.
So now your spot drill has got a 45 on it, like this. So this is a 90, and that's it going down in the hole. So we just have to do, and it's bigger than the hole. It always has to be bigger than the hole. So I think I used a 3/4.
Yeah.
No, 3/4 is not really bigger, but okay. This should be the same probably. So now you take this number and you divide by 2. So it'd be 350. I can get more.
Yeah.
Now, you have to go back to the top and we took off the last pass off the top, because that's from 0, and 0 is now lower, right? So the last pass we took off with our shell mill is right here. It was 125,000 feet. Remember? We took off the top. So you have to add that to that 390. 0.390, and you add the 125. So you get 5, 11, carry the 1, 4, 550, 550. How close is that to what I have up here? Left side, right side, spot drill. I got 5325. So my jigger is bigger. And then if you rate a 48, and then we go to the next hole. And next hole. So we just did this hole. Now we're going to this hole. And you don't have to put on there the coordinates that change. Now this hole's going to feet, right? So if you look, I changed the Z to a half of whatever that was when I calculated it out. Okay. So 250. You can take this by times 2 and you can figure out what whole side that would do. 387. Not that big. So that was the whole one. So we changed the height so we don't go deep on this hole, which is why X changed, or Z changed. And then X is 0. I don't need a Y because they're on a straight row. So Y doesn't change. So I've got my holes right here. Like, let's just start with you. Like this. I've got big hole, little hole, big hole. We just did this one. And they're all on the same Y. Because they're all the same line. So then we move over and we do this one. So we need an X position to tell it where to go to. And then we need a Z to tell it what the height difference is. Now if you wanted to, you could have skipped that one, done this one. So you only had to put in an X. And then come back into this one, but I just went straight across. Faster for the machine. A couple more lights in front of it, but not much. And then, so that's the middle hole. And then the other hole, we go back to the numbers we had before except positive. So 1.937 with the depth of this, which is right here. So I did this hole, and then I did this hole, and then I did that hole. So to do this hole, you have to change the X and the Z because you changed the Z right here. Alright.
Wouldn't you just need to flip the one on the left side? Big hole.
You could do it like this. You could do, say you did this. So you do this hole, and you have these 3 holes, right?
Yeah.
So you have your X and Z for this hole. already, because we did it, right? So then if you wanted this to be, so if you wanted to do a 1, 2, 3 like that, then you would just change your X for this hole and leave Z alone. And then when you go to this hole, you change your X and your Z again. Like the way
But
I-
I'm saying, like, if you go from the middle, could you, then you go from 1 to 3 and then to 2? Would you be able to just, like, reverse what you have for 1 for 2?
Yeah, that's what I did. If you look, see this? It's positive, right? Or it's positive right here. This is negative.
Yeah.
And then right here, this is my depth. So I just went back to the same depth, which is right there. I saved a couple of moves because for the machine, because instead of going over and then coming back, I'm just going over and then going over some more. Just quicker. And it's not that big a deal to change it, is it? Then when you're done, get a G8 to Z of 2, which G8 is the cancel for. You do one of your little quizzes, this little
Cancel the cancel.
yeah. Usually if you have, say I use a 42, which is counter comp, we haven't done yet, what do you think cancel code for that is?
You're gonna have to
That's cutter comp, that's the cancel code for cutter comp,
There's just 40.
it's just a 40. You keep this one usually and you put a 0 in here. And that comes in your, so cancel code for like an G86. Cancel, take a guess what it would be.
Red light.
Uh-huh. You keep this number and then you turn that to
A 0.
so it's real for a reading hole. You already understand all this stuff, right? You understand how to get there too
What?
at this
yeah.
point? So now we can just go over the differences. So let's go back first. I did, this is the center hole. You see it says up here, it says drill for a reading hole. See the center hole's ringed, so that's the drill operation for it. So G83, looking River Company is 149. See how it exits way down? Because it says G83 is a what? G83 deep hole pack can cycle. So, G83 is peck, which when you think of peck, think of a woodpecker. Basically what it does, it goes peck, 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 okay? Make sense? Yeah. So, G83 has the 1.2, that's my finish depth. R is that retract where it goes to when it's done. Okay. Feed rate, and then the Q is how far it goes down before it comes back up. That's how far it pecks.
So
I'm gonna-
use how far down.
Yeah, so I've got it set at 0.2. It's gonna go from where it thinks 0 is, down 200 thousandths. Okay? And then it's gonna go back up, rapid. And then it's gonna come back down, except this time it's gonna add 200, so now it's down 400 until it's finished.
And then, okay, so it'll just keep adding until it's,
Until it gets to,
until 1.2.
My Z.
Right.
now you have to watch this also.
Yeah, I was just about to ask if the Z was like the total.
Because with, after we took the top of the part off, all of this stuff is programmed from where your sock was. So whatever you take off of the top, you have to add, like a counter for. I'll show you. So this is your reading hole. I did a G85, which is on page, or I actually have the question mark on the page. The G85 is what from that? Just looking at those.
Boring, bore out, can't cycle.
Which means it'll go in and feed rate, come back out of the feed rate. Can cycle, G85, Z up 1.2. Sounds familiar, that's 200,000 to the part, right? Retract to 100,000s and a feed rate of. What did we do when we were good at was it?
Definitely not. Wait, which was that by?
That's the reamer.
Shit, we had that at 72.
Yeah, see? Told you my fees were wrong.
I gotta use the restroom.
G80 cancels,
I'll just wait for this.
G80 cancels it. Okay? And then we go to the same height, 2 inches above. And these are basically the same from now on. You can look these up in your book. Drill, that's a PEC cycle, the same thing that one does. I kinda need to get out there with my 111 this morning, if that happens, I'm sure you this out there. Counter bore 750, this is where it gets a little weird, because when you do your depth, you have to add what we took off the top, so G83, that's the cycle I used. Let's see, it's probably, what's G83?
Deep peg hole. Deep
So-
peg drill can cycle.
And then, how many was it? 500?
Ooh,
Yeah, had to be half inch. So your bricks are a half inch. Deep,
one second.
bricks are a half inch deep. But remember, I took 125 off the top. That's where that 625 come from. Because the machine still think D0 is where the stock used to be.
Yeah.
Otherwise, you're gonna be short, and I did a peck of, your valve.
I forgot you facing though. A little bit.
So then, you do your, this is for the one hole. I go over and do the X for the last hole, so that's both holes. This is your first location right here. That's your last location. G80 cancels G83, and then you end your program. This would be G28, G91, which is spindle home, machine home, G28, G91. Y, that just brings the table straight forward and we'll slide the corner. And then G90 and then 30. The percent sign. Do not do the percent sign.
Yeah.
And that's it, man. Feel better now?
Yeah, definitely.
Go to the bathroom and I'll show you where your homework's at.